Hey everyone, and welcome to this animated explanation of depth-first search. Depth-first search is an algorithm that describes how to traverse a graph-like structure in order to find a value or reach a given state. Let's take a look at the graph on screen and see what is meant by depth-first. In order to traverse the graph, we need a starting point. So let's pick node 1 and mark it as our starting point. The next step is to move along the edges from our starting point to other reachable nodes. How we pick what edge to another node we take first is dependent on the implementation. In our case, we'll keep it simple and pick the edge that goes to the node with the smallest value. In our case, this is 3. So we move along the edge from 1 to 3 and take 3 as our new node to travel from. As you can see, 3 only has one edge going outward. So we take that edge and move to node 6. It now starts to become apparent in the visuals why it is called depth-first search. Besides it being clearly visible in this graph, in general, what is meant by depth-first is that a node's children and their children will be visited before a node's brothers and sisters are visited. Once we reach a node like 6, with no more edges to take, we mark the node as visited. Once a node has been marked as visited, when we reach it again via another edge, we know that there is no more valid paths or places we haven't been from that node to somewhere else, so we don't need to go there. Now that 6 has been marked as visited, we can go back to the node that initially discovered 6, which is 3. 3 doesn't have any edges to unvisited nodes either, so we mark it as visited and go back to 1. Now that we arrive back at 1, we see that there are 2 edges going to nodes that are unvisited, 4 and 5, and we go to 4 because 4 is the lower number. We can continue this method of traversing the nodes in order to explore the entire graph. Let's now take a look at how we can use this depth-first traversal method in order to search for a value in a graph. We create this new graph and we mark the value 7 as the value we want to search for. And in order to search for it, we simply apply our depth-first graph traversal method. So we take node 1 as our starting node, and then we look at all the edges, and then we move to node 3 because it's the smallest unvisited node we can reach. Next we look at all the edges from 3 and we pick the edge to 6 because it's the smallest. Then we see that 6 has no more edges, so we mark it as visited and go back to 3. 3 has one more edge that we can use, so we move along it and we reach the number 7, which is the number that we are searching for. So we can stop our depth-first traversal. Now that we found our number, we can return the information whether we found it or not, or we can return the path to the number 7, indicated in blue. Finally, now that we know how to search for an item and how that we can traverse our graph using the depth-first method, let's take a look at a case where depth-first search struggles. If we apply our depth-first search algorithm to this graph to find 7, we see that we visit almost every node before we reach the value 7 we'd like to find. This shows how the execution time of your depth-first search is really dependent on the structure of your graph. And besides picking a different algorithm that is better suited, we can also add constraints to our graph, just like in a binary search tree, in order to make wiser decisions about which edges to follow next. I hope you learned something new in this video. If you did, please leave a like. And if you want to see more content like this, consider subscribing. See you in the next video. Enjoy this depth-first search of a larger graph. Bye.